Hi everyone, it's Mr. Bennett here again. I'm just going to have a look at question 16 from 5E. So if we start there, first part of the question asks us to classify stationary points. So that means that we need to do the first derivative. So f of x for this will be equal to, the x becomes 1, and that will be plus e to the minus x times by the power, which is going to be minus 1. So we could rewrite that if we wanted to as equal to 1 take e to the minus x. Now we will find that when you have your first derivative, you want to find the stationary points when that derivative is equal to 0. So therefore we can say that 1 take e to the minus x is equal to 0. We can rearrange that equation, so 1 equals e to the minus x, take the ln of that, ln of 1 is equal to minus x. We know that the ln of 1 is equal to 0, so therefore x is equal to 0. If we do our sign diagram for that, and we've got our first derivative for x, got 0 there. I've now graphed this on our calculator. You can see that it's got a negative slope there and a positive slope there. So on our particular function we've got negative and positive. So therefore we have a local max, our local min, at 0. Now to find the other point we need to go into our calc value, and 0 will tell us our local min is at 0, 1. So going to there, so that's part A done. So we've found the stationary points and we've classified that stationary point. Now what happens to f of x as x goes to minus infinity? If we go back to our graph, you can see that that over there is obviously going to go off to positive infinity with that. If we look at our function for that, we know that as f of x, sorry, I need to rearrange that, I've made a mistake. So as x goes to minus infinity, we know that f of x goes to infinity. Now if we look at our equation, our original equation, we know that obviously that's going to become a very big negative number, and this one over here is going to become a very massive positive number. So that's actually going to be bigger than this one over here. So that sort of ties in with what we expect to see with our graph. Going to see, explain why the graph of f of x becomes more linear as x becomes large and positive. So if we're looking at our equation there, f of x is equal to x plus e to the minus x. Well, we know that as x goes to infinity, we know that that's obviously going to be a large positive number, but we know that e to the minus x is actually going to go to 0. So therefore our function really, f of x, is actually going to be really just equal to x. So therefore that's going to be a linear function. So that's really what we're expecting to see there with that. Going to the next part is finding the second derivative and determine the sign for all of x. So we already know from our graph what we're expecting to see. Because it's obviously convex, we're expecting to see that's positive. So let's do it. F double dashed of x is going to be equal to, now our original equation is 1 take e to the minus x, so the 1's going to go out and that's going to leave us with minus x, and then we have to differentiate that, so that will be simply equal to e to the minus x. Now we know that e to the x is always greater than 0, so therefore our first derivative, our second derivative sign diagram is just going to be positive, therefore convex for all x. Now scrolling up to the next bit, so obviously we have to sketch the graph with that. Now it's just a matter of going to your calculator and just copying that. Obviously the critical point that we need to label in our graph is going to be that local min, which is at 0, 1. Everything else is going, and you need to make sure that you draw that part over there as being like a straight line, and that obviously curves off to negative infinity. The last part of this question asks us to deduce that that is actually the case for all of x. Now we know our local min for that, so that was E is graphing it, and you can do that yourself. Part F, we have to deduce that, so we know that for this function, f of x, our local min is going to be at, say, negative 1. So we know that f of x is actually always greater than 1, don't we? Right, so therefore what we can say is that x plus e to the minus x is always greater than equal to 1. And so therefore we can rearrange that and say e to the x minus x is greater than 1 and take x. And that's it. Good luck with the rest of the questions in there, and if you have some problems, please make sure you catch up with me during class time. Thank you for listening. As always, thank you, Mr. Bennett.